So my name is Ziad Al-Jabari. I'm lead TPM and chief of staff at Google, and I previously worked in robotics at Amazon. And today we'll explore how machine learning and robotics are actually making more work more efficient and enjoyable, and how AI is fueling that revolution in terms of robotics in creation, in wealth creation. Um, so I think you probably order from Amazon, some of you, not all of you, order products from Amazon, but have you ever wondered how many millions of products um, you order online are delivered so quickly and so efficiently? I'll tell you a secret. The secret lies within the walls of Amazon fulfillment centers and the unique, really the unique symphony of automation that is behind that. And this is what I call the Amazon magic. And so within these walls, robotics and AI, they're transforming the way we store, pick, pack, ship our items to keep our world running. And these intelligent machines are guided by AI algorithms that usually handle very repetitive tasks with extreme precision and higher efficiency and throughput rates, so that human workers can be freed up and work on and focus on higher level functions that require human brain. So I'll describe to you how the Amazon robotics system work. Um, so if you follow my pointer, so this is an Amazon associate who's gonna, an order has been placed in the system, and there is a picking station where he's gonna pick this item so that they can ship it after that. What you're gonna see here, the the, the rectangles that are in yellow, these are the robots that are either charging, at the bottom of of the cage. That's not an MMA cage, close enough. And then they're gonna come to this picker by looking at directing their route through barcodes that are defined in the cloud, and a predefined algorithm. So this is the old system design that was using barcodes. No receptors that is gonna uh, detect what the environment is. Right now, Amazon uses fully autonomous robots without the use of those barcodes. And you can imagine these are like um, kind of like mini Teslas or Waymos that are circulating, and the amount of data that is fueling this real time below the kind of like optimization of routes is pretty incredible. Looking at images, looking at videos, and so on. Um, and then on the other side, you have associates here on the right side that are actually stowing, so putting items into bins. These are, experimentally was, um, proven that stowing randomly gives you, the best information in terms of where to find those items in the future. And behind all of these, there are AI algorithms. So for example, I'll give you an example. So you're gonna pick an item. You have multiple choices for those bins to come. What we're gonna do is that the behind the hood algorithms are gonna select the bin that has multiple items for your pick order. This way, you minimize the time that this bin or this robot is gonna take to come all the way to the picker station. So huge efficiency if you pick 2 3 items from a bin versus just one. Another algorithm that is behind ML that is optimizing those processes is estimating the time accurately, which is a hard problem. Um, that this bin, as to how long this bin is gonna come to the picking station, as well as based on also the human inputs, the peak rate of of the associates calculate how much work is needed. So there is always optimization that is done real time with large amount of data and optimization that is working behind the hood. That's only one part of the Amazon robotics system. There are those material handling equipment that you've probably seen on TV, belts that are actually bringing all of these items inbound or outbound to the cage, to the robotic cage. And about kilometers and miles of belts for each fulfillment centers. I forgot to say, typically an Amazon fulfillment center has between 3,000 and 4,000 robots. So that's also, and you multiply it by the number of fulfillment centers throughout the world. So you get an idea about food storage and ML that is behind it. So you have the MHE. You also have smart packaging machines that are usually not produced by Amazon, so different systems and software that needs to be smoothly integrated and works in tandem with the robotic system. And you have also, the delivery. I don't know if you've seen this robot. It's called Dex. So it does the last mile delivery. It goes from the truck to your house. It's fully autonomous and delivers the item to you at your doorstep. So all of this, should work together. And the robots themselves, as I mentioned, they're just part of the equation. The true magic behind this is lies in the AI that governs their movements. These ML algorithms, they analyze huge amounts of data, optimize routes, predict product demand, ensure that the operations run smoothly. And like in an orchestra, AI would be the conductor for this robotic orchestra, directing each movement for maximum efficiency and productivity. So AI is driving this magic, but there are a few different pieces that we should have as a prerequisite so that this whole system works. As I mentioned, there are multiple systems, multiple softwares that run on different environments that need to be integrated from suppliers, internal tech stacks that might also be different. So the first step in this is to have unsiloed data that is joint um, and that you can leverage either for analytical purposes, or operational purposes to make those ML optimizations real time. And also enable the robots to interact with one another and understand their surroundings. Then, because sometimes the processes could vary, although Amazon tries for standardization um, across different time zones and regions. There could be some specificity due to the labor regulations and so on. And some processes can vary from country to country or from system to system. And this is where the advanced analytics, joining this data, leveraging this big data, can help you get a 360 view, so that operations and executive leadership have a bird's eye view of what's going on in the system, identify systemic issues, outliers, and so on. And then finally, all of these processes behind the optimizations can be optimized, can be enhanced by AI. Um, you know, uh, a simple example: there are a bunch of experimentations, that are happening across the network on a daily basis. I want to say maybe hundreds, if not thousands, of experiments going on, and then. Um, one of those experiments is, leveraging optical recognition and scale, so you can identify items that you're picking without having to scan a barcode. So that's probably saves you 1 second or 2 seconds, But at the Amazon scale, if you can do this, multiplied by the number of items that you ship, multiplied by the number of areas that you ship, that could easily help save millions of dollars. And then, now, let's imagine you're a customer, you're placing an order for, a book or whatever. And so what are those AI algorithms doing? So what they're gonna do, the moment you click on order, they're gonna instantly locate the book in the warehouse that optimizes your delivery time. It's gonna direct a robotic arm to efficiently retrieve it from the stock or the inventory. And then meanwhile, you might have another robot that is preparing the packaging materials at the same time. And yet another one that might be transporting the order to the shipping area. So all of this, seamless collaboration between machines, AI ensures that millions of orders are fulfilled with speed and accuracy to your doorstep, so that it can maximize customer satisfaction. And because images and videos are louder than words, Julian, if you can help me launch the video from your side, we're gonna take a look at how these warehouses and robots work in practice.
Let's go.
Robots, artificial intelligence. Amazon says it's revolutionizing the way consumers get their orders. It comes as e-commerce sales are predicted to grow at least 10% this holiday season, reaching $200 from robots. Amazon alone estimated to deliver 13.5 million parcels each day.
And it's all about innovation. I'm inside Boss 27. This is a state-of-the-art facility just outside of Boston. And with me now is Amazon's Chief Technologist for Robotics, Ty Brady. Ty, thanks for being here.
My pleasure.
So this is the first time the public will see some of the new technology you are rolling out for the holidays. What happens in a lab like this?
We are reimagining the future of robotics so that you can do your holiday shopping even better.
Today, Amazon launches Sequoia, its brand new robotic system in Houston. The company says it's capable of stocking merchandise 75% more quickly and delivering your orders 25% faster.
What was the problem you were trying to solve with Sequoia?
We want to offer a wider selection for our customers. We want to do that in a very efficient manner so we can pass on a low cost to our customers.
Brady says Sequoia also makes it safer for employees, reducing the number of accidents and repetitive stress injuries.
So you don't have to get on a ladder, you don't have to bend down on your knees, you don't have to reach up really high.
They're able to bring these totes from the warehouse to a workstation like this, where I met up with David Guerin, who helped design and build Sequoia.
A machine has gotten this item out of the warehouse, brought it over here, and now what happens?
Now the associate finds the item that's up on the screen. We take it out.
This is a yellow phone case?
We scan it.
Okay.
We put it in a tote to be sent to another part of the building for packaging. We let the system know it's in there, and then this will cycle through and deliver us another tote to pick something else out of.
And just how do those towers move around? Meet Hercules. Today is graduation day. The finished robots form a line and drive themselves onto their own shipping pallets, where they'll head off to work at fulfillment centers around the world. Amazon is also introducing Digit. This new bipedal robot can grab and move orders in warehouse spaces not designed for humans.
So I think something a lot of people are curious about is what happens between the time they click buy now and the product arrives at their doorstep. You're going to walk me through that.
Sounds good.
Okay, so I'm going to buy what is a bestseller on Amazon right now.
All right, very good.
The Instant Pot. It's going to be hot this holiday too.
Be hot, right on your phone, ready to go.
Yeah, I'm going to add it to my cart.
By the time you did that,
Yeah.
I've sourced every Instant Pot inside our network to figure out what's the best way to bring that to your house.
The system found my Instant Pot at a fulfillment center in Penns Grove, New Jersey. From there, it was driven to Carteret, New Jersey, where it was boxed, labeled, and loaded onto another truck, headed for a distribution center in the Bronx. That's where the delivery van picked it up and dropped it off the next day at 6:48 p.m. to me.
Welcome to my office.
The company also had more than 10,000 Rivian electric vans across the US to reduce its environmental impact. Branson Ramirez drives one.
I can do about 150 stops, maybe 250 to 300 packages.
New technology evolving to get us what we want faster and more sustainably this holiday season.
And here's the thing, Amazon is not alone in gearing up for the holidays. Retailers across the board are also getting ready. Walmart opened 3 new fulfillment centers, 36 drone delivery hubs, and Target
Can't
is
I
out
think we can stop the video?
just for this holiday shopping
But
season.
it all looks cool, especially the robots.
Yeah.
All right, so uh, you probably know a bunch of stuff, but I was also kind of like amazed at seeing these new humanoid robots replacing humans, helping them. So that's when I said that I was amazed by the speed at how robotics can advance, it's not a lie. um, all right, so we what so far what we described is the happy path where all of these system work in a nice fashion, and this Amazon magic that can come out of it. But stuff happen, and machines can break down, systems can stop working, and then when it happens, an hour of disruption of an Amazon fulfillment center, that's millions of dollars. Again, that is impacting customers, unhappy customers, um, and that has a huge impact on the operations for this kind of business that is relatively low margin. So that's why I'm going to present to you one of the projects I worked on in the past, and giving you how a simple system design on how we can solve it, which is related to IoT. All of these sensors that we have in the warehouses and that communicate between each other, and how we can predict that a problem is going to arise. So basically, the use case is the following. Disruptions can cause a huge loss, also for in terms of revenues for the company. You can think about it from a big company like Amazon, but also for a small manufacturer that has many competitors. Imagine that costs $1 million, $2 million, $10 million breaks down. That's the whole system that is endangered, and it could even sometimes mean that it's the business is going to shut down, because the customers are not going to be waiting for that specific supplier to solve their issues. So this is a very, very important problem. So that's the business case, and then what we're using, like in terms of sensors in this kind of systems, is what we call PLCs. So these are programmable logic controllers. They're actually the ones that describe the state of each of the machine, whether it's active, not active, in queue, charging. And it's very important to have the same standard, so that all of these different systems that are from multiple suppliers and providers have the same language. Just like us, we're going to speak English, or we're going to speak French. They should also be able to speak the same thing. So what we did is that we used that data, trained it based on historical data, to understand patterns on when a machine is going to break down. And of course, as you can imagine, so we've been using some ground truth data based on past incidents that happened. But everything, as you upgrade your system, upgrade your warehouse, new design come in, you're gonna keep learning and learning and training your model to predict that. Typically, that's done through control charts. those charts that are between a certain to different a certain range, and as soon as it goes out of range, you can predict that something wrong is happening. And then the outcome of all of these is that we could basically reduce the number of incidents, which translates in cost savings for Amazon, and improve like the overall reliability of the system. Better inventory and production planning processes that run smoother than when you have kind of like major events that are happening and that are disrupting your whole supply chain. Um, it helps also with experimentation, having those sensors and collecting this data to keep improving your models. And finally, uh, imagine, you know, there is probably no single operation manager that have a single view, a 360 view of what's going on in the whole network. Think hundreds of fulfillment centers that you're managing. These fulfillment centers, they're managed by general managers, and they don't know what is happening in the other warehouse. That imagine you're in New York, you have a warehouse in California. It's very hard for you to exchange and build knowledge around this. So this approach also helps you have this 360 view through advanced analytics, so you can understand if there are systemic issues within your network. Imagine 30 FCs, fulfillment centers are exhibiting the same problem. So this way, what you can do is identify that problem, go talk to your vendor, whether it's something that is a vendor driven or something that is internally driven, and come up with the root cause analysis and fix that problem for the entire network. Maybe it's a component, maybe it's a hardware, software issue. So these are the type of analysis that are very important for value engineering. In terms of the system, the infrastructure that is needed to support this, specifically from a software perspective and data perspective. So I'm gonna try to describe what we have, the different components in each of this schema. So you're gonna have your PLCs or your sensors that are coming from multiple sources here, that you're gonna be collecting through IoT, through AWS Greengrass, which is a managed service from Amazon. Then you're gonna be ingesting this data, and this data, usually they are raw logs, just giving you the state of a machine. But you wanna be able to translate this in terms of translate this in terms of KPIs that you're interested in, that you can measure on different granularity of time, whether it's below the second, 5 seconds, 3 minutes, 5 minutes, hourly, daily, and so on. So you can do this through the Kinesis suite of products. And then finally, the last piece, which is the tip of the iceberg, and that is the most important for you, is based on this transformation, you can add some ML ML algorithms through either open source libraries, Python, for example, using a serverless infrastructure with AWS Lambda. You can use Amazon SageMaker. I'm telling you Amazon SageMaker, Bedrock, but you can you can read ChatGPT, Gemini, all of these other foundational ML models that you can leverage, and then resurface this either through a dashboard, an app, a UI. And for operational data, the best practice is to use Amazon DynamoDB. So you can process large amount of data streaming in real time, and then sync it with other apps that need read write interactions, collaborations between all of these. So this is where all of these come through, and specifically for this predictive maintenance analysis, the analytics part is also very important in terms of training, testing, and validating that model. So So we talked a lot about the machines, but there is one thing that I want to highlight is that the human will, still be the central piece of this whole ecosystem. Um, you know, robots are there to help you automate some of the redundant activities that you're doing, and for the value add, high touch services or activities, there's going to be always associates humans that are going to be handling complex tasks, have their own, critical judgment, improve the processes, and so on. So and as you've seen in the video, that also helps with injuries. There are a few things that humans cannot, a few items that are too heavy for humans to handle. So that helps a lot with injuries. And a fun fact is actually, when you don't have automation in a fulfillment center, when you don't have robots, associates are gonna be walking probably 15 to 20 kilometers a day. That's huge. Great for your cardio, but it's very hard. In Amazon Robotics fulfillment centers, they're gonna walk maybe 2-3 kilometers a day, and probably all of the associates that I've talked to and interacted with, they love working with robots. So it's not kind of like a win-lose situation. It's a win-win for everyone. So, and last but not least, I think I'm gonna close on this statement. I think that the future of logistics is being built at companies like Amazon Robotics, but others like Otto, Waymo, and a lot of startups that are in this field. Um, the next individual industrial revolution that we've seen in the past it's not coming. It's actually here. And whether you're an engineer, a data scientist, or just simply passionate by um, interested in innovation, there is a place for you to contribute. So highly encourage you to be part of shaping a future where technology drives exceptional customer service in a more efficient and ethical way, and sustainable way as well. And together we can unlock the potential of this technology to revolutionize not just warehousing, but huge amounts of industries, and paving the way for a future that is filled with progress and efficiency. So with that, I'll finish my presentations and open it up to questions.
I have one question, which is slightly different from your business case of predictive maintenance, but can you comment on the storage within the warehouse, which, from what I understand, you not concentrate all the goods into one location, but you start to have the same goods in different places to try to minimize the trip.
Yeah.
Was told this. I mean, it's kind of humanly unintuitive, but this came out after, I don't know if it's through AI models or through some kind of design, or I think it was called fuzzy logic to come up with designs. And I'm wondering to what extent using now AI or whatever things could help do even better kind of storage distribution optimization based on that.
Yeah, so I'll repeat the question so I can make sure that I understand it well. So I think we mentioned earlier that random storing of items um, actually is the best way to optimize the routes to pick those items in the future. And the question is whether AI can you know contradict that hypothesis and status quo. I actually think you're right. I think you're right. So these kind of like heuristics is through testing, hypothesis. So that was at the time where I was working at Amazon, even before my time at Amazon. So in the 2010s, early 2010s, and there's only so much hypothesis that we can test. They probably tested a few of them. Now with AI, I think there is way more kind of like configurations that you can test. Not only this, but I'm gonna tell you about like a recent algorithms, like a research paper that I think Google DeepMind just published. Is what about these hard problems that don't have necessary that can only be solved by heuristics, meaning like optimizing the routes for a network of in logistics and trucks and so on. You can sometimes fall into a local optima, and not that is not maximizing your objective function. And so recently there has been a few algorithms that actually where you can inject creativity to them through mutations. So you have your algorithm, you're going to mutate them, and the speed of calculations for these kind of problems that are in heart, I think they're called, um, are way better and super easy, way more efficient to come up with an answer. So to your questions, I really think that there might be a better way to do this through AI, and specifically leveraging those mutating algorithms.
Okay, thank you.
And what is your current job at Google?
So currently at Google, I don't work with robotics, but a lot with data and AI. So I manage all. So the mission of Google is to organize the external data to users to make it helpful and accessible. I do exactly the same, but for internal data. So I manage all of the internal data and AI product suite to serve to help drive decisions internally. Any other questions?
Maybe you will continue robotics in the future, or now you move forward to data and
I like robots. I like working with humans. It's easier to work with robots, so I wouldn't say no.
okay.
Sounds great. Thanks for your time. Really appreciate it. And feel free to reach out. I think my details should be available online. And thanks for your time.
Thank you very much.
Thank you very much.
Thank you.
Bye.